Warning: this procedure should only be performed by or under the direct supervision of an experienced chemist. Please refer to the material safety data sheets of all chemicals for their hazards. Greetings, fellow nerds. So far, we've made a lot of videos on glow sticks and have always used the key ingredient of TCPO, or bis 2,4,6-trichlorophenyl oxalate. As promised, in this video, we're finally going to show you how to make it. Now, we like to work on large scale for dramatic effect, but since most of you attempting this will be doing it as part of a college or university course, you won't have access to that much chemical. So we'll do this on a small scale for you. If you want to make larger amounts, just scale it up. To get a sense of the size of the scale, guess how big that flask is. Okay, now let me show you. That is my hand, and this other flask is only 10 milliliters in volume, less than a tablespoon. Working at this size is cheap, but requires a steady hand and attention to detail. Okay, let's get started. Weigh out 700 milligrams of 2,4,6-trichlorophenol. Then add a tiny Teflon-coated magnetic stir bar and turn on the stirring. Now add 10 milliliters of dry toluene and stir until the trichlorophenol is completely dissolved. We use toluene dried by the sodium benzophenone method, but you can use toluene dried by molecular sieves or azeotropic distillation. At this point, I like to install a rubber septum onto the flask to prevent moisture from getting in during the cooling step, but this is optional. Okay, now get a syringe and inject 1 mole equivalent of triethylamine. I'll leave the exact calculation to you as exercise. If this trichlorophenol were perfectly pure, it wouldn't change color, but mine isn't. Some samples of trichlorophenol will even change to this reddish color. In any case, this is not a problem for this reaction, and you shouldn't be alarmed if it occurs. Okay, now place the flask into an ice bath and give it 5 minutes or so to cool down. If you're doing this on a larger scale, you should give it more time. Let me wipe off the fog here. Okay, now inject 0.5 mole equivalents of oxalyl chloride. I'm using a 2 molar solution because that's what I have on hand, but you may use pure oxalyl chloride or any other dilution as long as you have the right stoichiometry. This method should be performed slowly as it produces considerable heat. I time-lapsed this video, but I actually spent 5 minutes injecting it. If you're doing this on a large scale, add the oxalyl chloride dropwise and take however long is needed to keep the temperature down. Once everything is injected and still cold, take it out of the ice bath. It doesn't seem to be fully mixed here, so give it a good shake. Let it warm back to room temperature on its own. Okay, the mixture is ready, and first thing we need to do is filter off the unreacted chemicals. Use a vacuum flask and a glass-fitted Buckner funnel, and filter by the vacuum filtration technique. Okay, here is our crude TCPO product and a byproduct of triethylamine hydrochloride. To separate the two, we simply add 25 milliliters of methanol, which will dissolve all the triethylamine hydrochloride, but very little of the valuable TCPO. Give it a good stir to thoroughly dissolve all the byproducts. Hold on a second here, I need to get rid of this waste. Okay, vacuum filter it. Get rid of the waste. Now with an empty vacuum flask, put the vacuum on the TCPO powder for several minutes to thoroughly dry out all the methanol. Alright, carefully scrape it out. Oh yeah, remember to retrieve the stir bar we put in earlier. Okay, there we have it. Pure bis 2,4,6-trichlorophenyl oxalate, better known as TCPO. Okay, let's test our product. Get a 20 milliliter vial and add about 3 milligrams of 9,10-bisphenol-ethynyl anthracene, 300 milligrams of sodium acetate or sodium salicylate, then add 10 milliliters of ethyl acetate or diethyl phthalate. Finally, add your TCPO. Give the whole thing a good shake, then add in a few milliliters of 3% hydrogen peroxide. Let me get the lights. There you go, a successful glow stick reaction using TCPO. Thanks for watching. Please subscribe, rate, and comment. The primary foundation for this video was found in Professor McCaffrey's article entitled Demonstration in Chemiluminescence, found in the citation I'm displaying here. The article also details synthesis of luminol, acridinium esters, and other chemiluminescent substances in addition to TCPO.